Mapping and surveying professionals occasionally use the term datum, but what does it mean, and why are datums important? A datum is simply a standard reference point, set of points, or surface from which survey measurements are based. It's similar to the starting points you use when giving someone directions to your house, which usually include a point that they know, like a crossroads or a prominent building. For surveyors, that starting point is usually a nearby survey mark. When adjoining properties share these common starting points, it's easier to align them properly on a map. And when we all use a network of these marks spanning the continent, we share one national spatial reference system. For many decades, we have had two types of nationwide datums in the United States, horizontal and vertical, and they were generally separate from one another. Horizontal datums allow us to measure distances and directions across the surface of the Earth. Most horizontal datums define a zero line at the equator from which we measure north and south. There is also a zero line at the Greenwich meridian from which we measure east and west. Together, these lines provide a reference for latitude and longitude. Vertical datums are used to measure elevations and water depths. Sometimes the word height is used to refer to elevation information. Most vertical datums in North America use sea level as the basic reference plane from which we measure elevation changes. Because sea level varies along the coast for a variety of reasons, the idea of using multiple tide gauges to define the vertical datum was abandoned in 1988 in favor of using just one tide gauge. Now, thanks to the Global Positioning System, commonly known as GPS, and some other space-age techniques, we are no longer limited to separate horizontal and vertical datums. Today we have access to geometric datums, which combine latitude, longitude, height, and time information. The height information derived from GPS is relative to something called an ellipsoidal model of the Earth, instead of to sea level. While there are challenges mixing old and new positioning information, overall, new technologies like GPS help to improve the accuracy of our current datums. The North American datum of 1983, NAD 83, is the nation's horizontal or geometric datum. It provides latitude and longitude and some height information. The North American vertical datum of 1988, NAVD 88, is the nation's vertical datum, providing elevation information relative to a reference surface defined by mean sea level. U.S. territories have separate vertical datums. Unfortunately, NAD 83 and NAVD 88 aren't the only datums you will encounter. Before the current datums were defined, many maps were created using different starting points, and even today, people continue to change datums in an effort to make them more accurate. When combining data from different users or eras, it is important to transform all information to a common datum. Let's look at some examples of when and why using a consistent datum is important. Datums are commonly referenced on federal floodplain and topographic maps. Sometimes an older vertical datum for the United States is used rather than NAVD 88. In some areas of the country, especially in the West, differences between some vertical datums can be as much as 3 to 4 feet. This is pretty significant if you're trying to figure out if your house is in a floodplain. It's really important to know which datum your heights are referenced to. For any type of work where it's important for coordinates to be consistent with each other, it is critical that the same datum is used. If you are creating floodplain maps, marking property or land boundaries, designing levees or dams, building roads, or planning for coastal inundation scenarios, you must know about and use the correct datums.
Do you ever think about how location information impacts your work? Accurate positions and elevations are critical to construction projects, floodplain mapping, scientific endeavors, and much, much more. Surveyors use scientific instruments and field procedures to collect information about positions, distances, and elevations. Then, this information is used to create geodetic datums, reference frames used at a national level to assure consistency across mapping applications. Geodetic reference frames have a long history in the United States, dating back to the 1800s. In 1807, President Jefferson signed the act that established the Survey of the Coast. Work started by measuring angles and distances between points across the country. This formed a triangulation network that continued to be densified over the years. This network would become the basis of the future horizontal datums. To create the vertical datum, a highly accurate surveying technique called geodetic leveling was used to measure height differences across the country. During a 20-year period, beginning in 1877, a level line was surveyed across the entire United States. As the network of level lines across the country expanded, this became the basis for future vertical datums. There were many tools and instruments used to complete these geodetic surveys, and some are still used today. For example, theodolites have been used for centuries to measure angles. A variety of other tools have been used over the years to measure distances, including chains, bars, and invar tapes, continuing to today's total stations, which can measure angles as well as electronically measure distances. The tools for accurate elevation measurement have also remained fairly consistent over the years, with the use of level rods and a sighting instrument to measure the height differences between 2 points. Today, a laser may replace the use of a telescope, but the approach remains the same. Over many decades, surveyors used these tools to create a tremendously accurate reference system across the United States, with many applications and benefits. The North American datum of 1983, called NAD83, is the horizontal datum for the United States, and much of NAD83 is based on the extensive triangulation network established over decades. The North American vertical datum of 1988, or NAVD88, is based on an adjustment of leveling observations from across the country. Surveyors have worked for decades to create a tremendously accurate reference system across the United States that helps define such things as property boundaries and floodplains, and is used in many other applications. Today's geodetic datums are defined using data that has been collected since the 1800s and augmented with data and models that use today's state-of-the-art technology. Advances in science and technology, like the Global Positioning System, or GPS, let us build models and tools with greater precision and accuracy than was possible in the past. The North American datum of 1983, called NAD83, is the horizontal datum for the United States. NAD83 is based on a set of approximately 250,000 points. These points have positions that were determined both through the extensive triangulation network established over decades and newer GPS observations. All of these points were constrained to a geocentric origin, specifically the center of an ellipsoid model, which is a commonly used mathematical figure approximating the shape of the Earth. With the help of more recent satellite-based observations, we now know that NAD83 is misaligned to the most modern definitions of latitude and longitude by over 2 meters. Our ability to detect this misalignment comes from the current, more accurate understanding of the true center of the Earth. This offset causes many inconsistencies in mapping products referenced to NAD83 versus the datum based on the true center of the Earth. Looking at the vertical reference frame, the North American vertical datum of 1988, or NAVD88, is based on an extensive network of leveling observations from across the country. To make the network of observations internally consistent, one value was held constant, the local mean sea level value at Father Point, Rimouski, Quebec, Canada. Every leveling observation includes some random observational error as well as theoretical errors. While this averages out to less than 0.5 millimeter per mile, these errors actually accumulate to a total error of more than 1 meter between Miami, Florida, and Seattle, Washington. Additionally, the NAD83 positions and the NAVD88 elevations are inconsistent with the more accurate, up-to-date models that have evolved with advances in technology. These up-to-date models allow us to create a more accurate reference frame than the surveying methods and tools used in the past. Because we still need to use NAD83 positions and the NAVD88 elevations today, we have to artificially alter the updated models to fit with the existing reference systems. Much of the NAD83 and NAVD88 reference systems rely on marks in the ground that you must be able to physically access. Unfortunately, this physical infrastructure deteriorates over time. Marks often get disturbed. Sometimes this is accidental, as when landowners inadvertently destroy a mark on their property. Other times, marks are destroyed when roads are rebuilt or widened. Marks are intended to be very stable, so we attach them to the Earth as permanently as possible. However, physical events like frost heave or subsidence can move a mark if it is not attached to something more stable, like a deep bedrock structure. Any motion of a mark requires that coordinates be updated over time, an expensive and time-consuming task. We do have strategies for replacing marks that are about to be disturbed or destroyed, but it takes time and effort. It would be prohibitively expensive to duplicate the level of physical effort and labor used to create our current datums. To address the problems with the physical infrastructure of our current datums and to integrate information from the most current technology, NOAA's National Geodetic Survey plans to establish new datums to replace NAD83 and NAVD88. Surveying today relies heavily on the Global Positioning System, GPS, or similar systems from other countries, collectively known as Global Navigation Satellite Systems. Today's satellite-based technology can help people determine accurate positions and elevations more efficiently than in the past. The benefits of using GPS to determine accurate positions and elevations will be even greater when NGS defines new datums. Let's take a look at the planned new datums and some of their expected benefits. Horizontal positions are currently defined by the North American Datum of 1983, or NAD83. This will be replaced by a new geometric datum, which provides latitude, longitude, height, and time information. Vertical positions or elevations are currently defined by the North American Vertical Datum of 1988, or NAVD88. This will be replaced with the new vertical or geopotential datum. The new datums will help lessen the impact of aging physical infrastructure, like marks, that currently help define NAD83 and NAVD88. The new geometric datum that will replace NAD83 will rely completely on reference stations that continuously receive GPS information. NGS maintains the CORS network, which stands for Continuously Operating Reference Stations. Users can reference CORS to help accurately determine any geometric position, which includes latitude, longitude, and some elevation information. CORS provides elevation information computed using an ellipsoid model of the Earth. An ellipsoid can be used as a rough approximation of the shape of the Earth. However, we know that the Earth is not shaped like a perfect ellipsoid. As a result, we need another model, one that reflects the varied topography of the Earth, including features such as mountains and valleys. This new model, called a geoid, is based on the variations in gravity across the Earth's surface. The geoid model is the basis for the new vertical or geopotential datum. This new datum will combine the ellipsoid height and the geoid height at the same point to calculate its elevation. To help improve accuracy of the new vertical datum, NGS is completing a major project called Gravity for the Redefinition of the American Vertical Datum, or GravD. NGS is flying over the entire U.S. and collecting a unique, continuous gravity dataset that will help us build a better geoid model, which will improve the accuracy of elevations measured using GPS technology. When the new datums are adopted, positioning information for existing structures and marks will change. The scale of the change will vary depending on your location, ranging from 0.5 to 1.5 meters in a horizontal direction and 0 to 1.3 meters in elevation. These changes, based on our newest positioning technology and scientific knowledge, will provide more accurate positioning information. They will have impacts in areas ranging from transportation, construction, floodplain mapping, agriculture, and more. Even though the change is years away, the time to prepare is now. While tools will be available to facilitate the transformation of specific position information, it can take years to change products, services, or databases. You may want to begin examining current databases and records that may be impacted and plan for the effort required to update. In addition, many state and other governmental entities passed laws requiring that public works or maps reference NAD83 or NAVD88. Those laws or contracts will need to be changed to reflect the new datum. Starting to plan now will help you be well positioned for the change. Resources are available and continue to be developed by NOAA's National Geodetic Survey.